Welcome, everyone. Today, we're doing a deep dive into something that's, well, it's everywhere now, isn't it? Robotics and artificial intelligence and how they intersect.
Exactly. It's moving incredibly fast.
And we've got a great stack of sources you sent in covering the tech, the ethics, the future of work, all of it.
Yeah, a really comprehensive set. So our mission today is basically to unpack these together.
Right. Pull out the key takeaways, the really important insights to help you get a solid handle on this pretty complex topic.
Let's do it. Where should we start?
Let's start with the basics. Robotics itself. What are we actually talking about?
Well, the sources define it pretty clearly. It's the science, the engineering of creating and using robots.
Machines that are programmed to do stuff,
Right.
either on their own or maybe with some human guidance.
Precisely. One source called it a tech dance between computers and machines. I liked that.
Yeah, giving things the ability to move and act in the physical world.
And then AI robotics layers something crucial on top of that. It fuses that physical hardware, the robot, with AI. So machine learning, computer vision, language processing, all that intelligence.
Okay, so what's the big leap there? How's an AI robot different from, I don't know, a basic factory robot arm?
That's the core difference. Your traditional robot is amazing at doing one specific pre-programmed task over and over. Think, welding the same spot on a car body.
Very precise, very repetitive.
Exactly. But it can't really adapt if something changes. An AI robot, though, it can perceive its surroundings.
Using sensors and vision and things.
Right. And it can interpret that information, adapt to unexpected stuff, and this is key, it learns. It uses data to get better, to figure out challenges it wasn't explicitly programmed for.
So it's not just following instructions, it's kind of thinking, making decisions.
In a way, yes, making informed decisions in real time based on what it senses and learns. That adaptability is huge.
Okay, so let's pull back the curtain a little. How do these things actually work? The sources mention control systems being central.
Absolutely. Control systems are like the brain and nervous system for these machines. A really key concept is closed-loop control.
Or feedback control.
Yeah, same thing, feedback control. Think about it like this. The system has a goal, a desired state.
Like move this arm to point B.
Exactly. The system constantly checks where the arm actually is, compares that to point B, and sees the difference. That difference is the error signal.
Okay.
And it uses that error signal to adjust its actions, telling the motors what to do to reduce the error and get closer to point B.
So it's always checking and correcting itself, like a thermostat.
That's a perfect analogy. Checking the temperature, turning the heat on or off to match the setting. It's that constant loop of measure, compare, adjust.
Got it. And the sources say this gets really complicated with multi-input, multi-output systems, like controlling a helicopter.
Oh, yeah. Something like the twin rotor system mentioned, TRMS, you've got multiple things to control and multiple inputs affecting them all simultaneously. It takes sophisticated methods like the linear quadratic controller or LQR they mention, just to keep things stable and precise.
Right. Sounds like some heavy-duty math involved.
Definitely. And then you layer on smart control systems. That's where the AI really comes in, using things like neural networks, genetic algorithms, or fuzzy logic.
Fuzzy logic, that sounds a bit vague. How does that help control a robot?
Yeah, the name is a bit funny, but it's actually really powerful for dealing with information that isn't clear-cut yes-no or precise numbers, things that are more, well, fuzzy.
Like what?
You use it all the time. In washing machines adjusting cycles based on how dirty the clothes seem, or cameras focusing. The source gives a great example with EMG signals.
Electromyography from muscles.
Exactly, the electrical signals your muscles create when you intend to move. They're noisy, complex signals.
So not simple on-off data.
Not at all. Fuzzy logic is good at processing that kind of noisy, fuzzy input, filtering it, finding the patterns that mean I want to move my hand this way, and translating it into commands for, say, a prosthetic limb or a robot.
Wow, so it bridges the gap between messy biological signals and clean robot commands.
In essence, yeah. It helps machines understand less precise, more human-like input.
That's fascinating. The sources also quickly mention some other technical things like passivity-based control and master-slave teleoperator systems for handling delays when controlling robots remotely.
Right, those deal with specific challenges in robotics control, especially things like time lag. It just shows the depth of engineering needed.
Absolutely. It's this blend of mechanical, electrical software, and now AI is the glue making it all smart.
Couldn't have put it better myself.
So let's step back from the technical bits and look at the actual robots out there. The sources cover quite a range, don't they?
They really do. You've got humanoids obviously designed to look and maybe move like people, used a lot in research, maybe some customer service roles.
Right. And then cobots, collaborative
Yeah,
robots.
theirs are specifically designed with safety in mind, lots of sensors, so they can work right next to humans on a factory floor or even in healthcare settings.
And we're seeing more in homes too, right?
Yeah,
Domestic robots for cleaning, maybe cooking soon.
definitely a growing area. And hospitals are a huge field robots assisting in surgery, delivering meds, leaving patients, lots of potential to improve care and safety.
The sources also list articulated robots, those multi-jointed arms we see in factories.
Great for complex tasks, yeah. And Cartesian robots that move on simple XYZ axes, often for things like packaging.
And then just industrial robots is a big category for all those manufacturing tasks, welding, painting, assembly.
Plus the broad category of medical robots covering everything from surgical tools to rehab devices.
The Forbes piece had some cool company examples. Boston Dynamics is always flashy with Spot and Atlas.
Oh yeah, spot inspecting dangerous places, Atlas looking like something out of science fiction, potentially for factory work down the line, very advanced stuff.
And the big industrial players, Fanuc, ABB, they're integrating AI now too.
Absolutely. Their robots are the backbone of manufacturing for companies like Toyota and Siemens. They need that precision and reliability, and AI adds flexibility.
And then there's agility robotics with Digit, the walking one.
Right, the bipedal robot, designed to navigate human spaces like warehouses. Amazon's actually testing them.
Speaking of Amazon, the scale there is just mind-blowing. Over 750,000 robots.
It's incredible, and they have specialized ones like Sparrow for picking items, Cardinal for stacking, and Proteus, that's the autonomous cart that can just navigate around human workers.
Shows how they're using different types of robots for different jobs within the same environment.
Exactly, strategy.
Tesla's Optimus humanoid is also mentioned, though it seems much earlier stage.
Still very much in development, yeah, but aimed at similar factory tasks eventually.
And it's important to mention companies like NVIDIA too, right? They're not building the robots themselves necessarily.
But they're building the brains.
Hmm.
The AI platforms like Isaac, the simulation tools, they're enabling a lot of this development across the industry.
So these examples really show the sheer breadth and the increasing sophistication of AI robotics across so many areas.
No doubt about it.
So why now? Why this huge surge in AI robotics recently? What's driving it?
Well, the sources point to a few converging factors. Businesses always want more efficiency, better safety, that's constant.
Sure.
But there's also immense pressure from rising demand, especially e-commerce, and really significant labor shortages in many sectors and countries.
The labor shortage angle is key. Robots filling gaps.
It's a major driver. And you see it in the market numbers. We're talking, what, over $50 billion globally this year, heading towards potentially $100 billion, maybe even close to $200 billion in the next few years.
Huge growth.
It signals serious investment. Companies are seeing clear benefits, cutting costs, improving safety by taking people out of dangerous jobs, and just scaling up to meet demand they couldn't otherwise.
Okay, that makes sense from a business perspective. But let's pivot now, because as these systems get more powerful, the ethical questions get louder. The Stanford Encyclopedia source really digs into this.
Yeah, and this is, for me, maybe the most crucial part of the discussion, moving beyond how they work to what it all means.
Policies are trying to catch up, like the EU talking about trustworthy AI.
Right, concepts like making sure AI is lawful, ethical, technically sound, with requirements for human oversight, privacy, transparency, fairness, accountability. It's a framework.
And the idea that responsible design is as vital as responsible use, building ethics in from the start.
That's a really important point from Verbeek, cited in the source. Okay, so let's break down some of the specific debates. Privacy and surveillance is huge.
Definitely feels like AI supercharges data collection, doesn't it? Both broad and really targeted.
Massively. It's just harder to control your data now. Things like facial recognition, tracking your online behavior. One source said it creates a frighteningly complete picture of us. And this ties into the business model of many free online services, right? The idea of surveillance capitalism. Your data is the product being sold.
These systems might know us better than we know ourselves in some ways,
That's the unsettling argument made. Plus, you've got deepfakes now.
making it hard to trust video or audio evidence.
Exactly. Which erodes trust, especially as we rely more on digital stuff. And there's this tension. The AI often works better with more data, but more data collection raises more privacy concerns.
It's a trade-off. And policies differ globally, like the EU's GDPR focusing hard on privacy, while maybe the US or China prioritize growth more.
That's a simplification, but yeah, different approaches reflect different priorities.
Okay, another big one, bias. How does bias creep into AI?
Well, bias here means unfairness. The AI makes judgments based on things it shouldn't, leading to discrimination. It often comes from the data used to train it.
If the data reflects historical biases, like biased hiring data,
Exactly. The AI learns those patterns, even if they're unfair or based on things like race or gender that shouldn't matter for the decision. And these human biases can be unconscious, making it even trickier.
can you just technically remove the bias?
It's incredibly hard. How do you even define fairness mathematically for an algorithm?
Right.
Or concepts like race? It's not straightforward.
And the right to explanation they mentioned, like in GDPR, does the AI explain itself?
Not really in a human sense. It's more about understanding which factors led to a decision, algorithmic accountability reporting. But it doesn't mean the AI provides a justification. The core challenge is preventing these systems from making inequality worse.
Which leads us to probably the most talked about impact, jobs, automation and employment.
Right. Huge productivity potential, obviously. But the impact on jobs is, well, it's complicated.
The sources talk about job polarization, the dumbbell shape. What's that?
It means demand grows for high-skilled jobs, the people designing and managing the AI, complex problem solvers, and also for low-skill service jobs that need human touch and flexibility, like elder care or hospitality.
Okay.
But the jobs in the middle, those mid-skill, routine, predictable tasks, think data entry, some factory work, administrative support, those are the ones most vulnerable to automation.
So not necessarily wiping out all jobs, but hollowing out the middle.
That's the concern. And opinions really differ on whether new jobs and wealth created will offset this. We've seen shifts before, like farming to factories.
But this feels different. Digital automation replacing thinking tasks, not just muscle. And it's cheap to copy software.
That's the argument that this wave could be faster, more disruptive. However, some research, like from MIT, suggests companies adopting robots often grow and hire more overall, just different kinds of workers.
Like the Amazon example, fewer pickers maybe, but new jobs maintaining the robots.
Right. But the transition is the hard part. Can workers whose jobs disappear easily retrain? Especially older workers, does everyone have access to the needed education?
Big risk of widening inequality if the benefits mostly go to the highly skilled.
Definitely. But there are upsides too. Addressing labor shortages, especially in aging countries, and making work safer by automating dangerous tasks.
So the future isn't set in stone. It depends on adaptation, reskilling policies.
Exactly. How we manage this transition is key to making sure the benefits are shared. It needs proactive steps.
Okay, what about autonomous systems specifically, like weapons?
Yeah, the sources bring up autonomous weapons, killer robots, as they're sometimes called. Things like drones or missiles that can select and attack targets without a human directly pulling the trigger.
The concerns there are pretty obvious, I guess.
Lowering the bar for going to war, maybe?
Yeah.
Reducing accountability? The retribution gap, if something goes wrong, who's responsible? And the risk of proliferation to rogue states or non-state actors.
Plus, can a machine really follow the complex rules of war, like distinguishing civilians?
That's a central debate. Can they comply with international humanitarian law? Does being killed by a machine violate human dignity? These are deep questions.
People talk about keeping humans in the loop or on the loop.
Right, maintaining meaningful human control. There's this idea of a responsibility gap. Maybe neither the human nor the machine is truly responsible. But an alternative view focuses more on managing risk. Who decides to deploy these systems? Who benefits? Who bears the risk?
Shifting from blame to risk distribution.
Yeah.
Interesting. And then, even more philosophically, artificial moral agents. Machines making moral choices.
The sources touch on this. Different levels of ethical agency are proposed, from just having ethical consequences up to hypothetical full ethical agents. But a key point is that even a machine programmed to act ethically might be competent without comprehension. It follows rules but doesn't understand morality like a human.
And the ultimate fear, existential risk, superintelligence.
Yeah, the most dramatic concern. Robots taking over an idea that's been around since Apex Play, or even earlier. The modern version often hinges on the intelligence explosion idea.
Right, I.J. Good in the 60s.
Yeah. If we build an AI that's generally smarter than us, it could design an even smarter AI, and so on,
A runaway process.
potentially leading to intelligence far beyond our control or comprehension. Good said the first ultra-intelligent machine is the last invention we need if it tells us how to control it.
The fear isn't necessarily evil robots, but maybe just incredibly powerful systems with goals that aren't aligned with ours.
Exactly. Indifference could be just as dangerous as malice if you have that level of power and intelligence optimizing for some goal that happens to conflict with human survival or well-being.
Wow. Okay, so we've gone from control loops for robot arms all the way to potential existential threats. Quite the journey through these sources.
It really covers the spectrum, doesn't it? From the deep engineering to the profound societal and ethical
It
dimensions.
underscores that this isn't just a tech issue, it's deeply human.
Eh,
So wrapping this up, what does this all mean for you, listening? Whether you want to work in this field or just navigate the world it's creating.
Well, the practical advice from the Beginner's Guide source focuses on foundational skills. Math, science, definitely programming Python gets mentioned a lot.
Electronics, circuits,
hmm
but also softer skills.
Yeah, creativity, problem solving, teamwork. These complex systems require collaboration.
And learning seems more accessible now. Online courses, competitions.
Absolutely. Workshops, networking, just using Google and YouTube effectively. The sources emphasize it's a journey. You don't need to know everything at once. Asking for help is key.
Cultivating that curiosity, basically.
Right. And being willing to learn the fundamentals and experiment.
So we've covered a huge amount today in this deep dive. The nuts and bolts of control systems, the different types of robots emerging, the economic drivers, the really complex ethical terrain, privacy, bias, jobs, autonomy, even morality and existence,
It's clear it's a field with just incredible potential, but also challenges that demand really careful thought and proactive engagement from everyone.
which leaves us and you with a final thought to ponder. As these AI robotic systems get more capable, more autonomous, the questions just get bigger, don't they? Who is really in control? How do we assign responsibility? And maybe the biggest question of all, how do we make sure the incredible benefits are shared fairly and the risks are managed wisely? What steps should you take starting now to navigate and maybe even help shape this future?